So, a mule drags a felled tree, mass 500, by means of a horizontal rope across horizontal ground. So let's just sketch that. Here's my object, horizontal rope, horizontal ground. Got tension in the rope. I have mg coming down. I have my reactionary force, which is from this point here, just not seeing it going through. Do I have friction in this case? I do. I have the coefficient of friction. Mu is 0.4. So instead of calling this one F, I'm just going to call this mu r from now on. Mu r. Coming back this way, friction, because we can get it up with the resultant force that we can call F2. So 4 things going on. And now let's see what information that we have. We have mg, because we have the mass is 500, so we have 500g, which is equal to 59.8, which is 49 with 2 zeros. 4,900 newtons coming down. So we can say then that R, the opposing force, has to be equal to 4,900. My friction force, friction, is equal to mu times R. In this case, we have mu to be 0.4, 0.4 by 4,900, which is 4 by 490, which is 1960 newtons. So that's mu r, my friction force. So we're also told tension in the rope is 3 kilonewtons, and that's 3,000 newtons. So my resultant force is equal to 3,000 minus 1960. It's going in this direction. 3,000 minus 1960. That's my F. And that's equal to mass times acceleration. So I'm going to have 2,1040 is equal to, it's equal to mass 500 kilos, 500A. So the acceleration in this case is 2 point, and that works out to be 0.8 meters per second squared, or ms to the minus 2. Okay, question 2. So a man pushes a deck of mass 50 across a floor by applying a horizontal force of 300 newtons. We're told the coefficient of friction between the desk, sorry, not a deck, a desk, and the floor is 0.6. Find A again. So I just sketched the diagram here. What do we know? We have friction. So I have mu r, I have tension, I have a reactionary force, and I have mg. So what's m? 50 kilos, so 50g, which is equal to 98 by 5, which is equal to 490 newtons. My reaction. So we can say R is equal to the 490. Therefore mu R, we're told mu is 0.6, mu R is equal to 490 by 0.6. 649s are 294 newtons. So this is my friction force. Friction, 294. That's back in this direction here. I can put it in, 294. We were told the pulling force, or the horizontal force, is 300. So you can see here, I'll just do it down here. The resultant force, again, for my red, is 300 minus 294. That's equal to mass, 50, times acceleration. 6 is equal to 50A. So A is equal to 6 over 50, 12 over 100, 0.12 ms meters per second squared. Okay, number 3. A couple more steps to this. So a barman slides a pint glass of beer. So here's my glass. Let me say it's going in this direction here. So he slides a pint glass of beer along the counter so that it leaves her hand, it's a bar woman, sorry, not a barman, with a speed of 3.5 meters per second. The mass of the glass is 1 kilo, so we have mg is going to just be 1g, which is 9.8, which is my R. So we can say R is equal to 9.8, and we're given mu to be 1/7. So my friction force is equal to 9.8 by 1/7, and 9.8 divided by 7 is 1.4 newtons. Then we're asked for the deceleration of the glass, slowing down. So let's put in our other forces. We have mu r going this way, which is 1.4. In this direction, because it's sliding and there's no string attached, we can say this is 0. So my resultant force, it's going in this direction, so 0 minus 1.4, which is equal to minus 1.4. So that's my F. F is equal to ma. So minus 1.4 is equal to the mass, which was 1 times a. So a is equal to minus 1.4 meters per second squared. And then the distance which the glass will travel, that's where that speed is going to come in. The distance which the glass will travel before coming to rest, we were given speed here of 3.5. So we have u is 3.5. It's coming to rest. Final velocity is 0. We have acceleration is minus 1.4, and we're asked for distance s. So v squared is equal to u squared plus 2as. It comes to rest, started at 3.5 plus twice the acceleration by the distance. So my distance here is going to be 3.5 squared over twice by 1.4. That's equal to 4.375. And we're dealing in meters as it's traveling in meters per second. That's it for number 3. Number 4. So slaves are building a pyramid. They're ordered to drag a stone 1,000 kilos across horizontal ground. Coefficient of friction is 1/4. And if each slave can pull with a horizontal force of 250 newtons, find the limiting friction force. We'll do that first. So do a little diagram. So we've got our poor slaves. They're dragging this big stone. There's friction. There's a reaction. There's mg, which we're going to have as 1,000 g. 1,000 by 9.8, so 9,800 newtons. It's going down, and they're able to drag in this direction 250 each. So how many of them will be needed? Let's have a look here. Just do a proper arrow. So we can say that R is equal to 9,800. F is equal to mu R. So this F is going to be 1/4 of 9,800, which is 50 less than 2,500. So 2,450 newtons is this limiting friction. So we need to pull it with more than this force to get it moving. So my limiting friction, if I divide it by the 250 times how many of them are we going to need? You see it's going to be 10. We're going to need 2,500. 2, 4. Why do I keep putting the 0 next? 2,450 divided by 250 is going to be, well, it's going to be 9 point something. 9.8, is it? 9.8, bang on. So we're going to need 10 slaves, the first slaves. And then is there a third part to this question? The acceleration of the stone if the minimum number of slaves do this job. Okay, so now we have our forces. So the resultant force is, what is it, 2,500? It's going to be 50 here minus 2,450. So 50 newtons. So that 50 is going to be equal to ma, mass times acceleration, and the mass was 1,000. So A here is going to be 50 over 1,000, 5 over 100, 1 over 20, which is equal to 0.05 ms to the minus 2.